Hello everyone, this is Ma'am Berlin, and on this lecture video, we will be tackling about van der Waals equation, its definition, and some sample computations related to that. When we talk about van der Waals equation, typically in chemistry, which is much more related in thermodynamics or also what is known as thermochemistry. The van der Waals equation is an equation of state which extends the ideal gas law to include the effects of interaction between molecules of a gas, as well as accounting for the finite size of the molecules. Now, van der Waals equation, this one is an equation relating to the relationship between pressure, volume, temperature, and amount of real gases. Take note of the real gases. For a real gas containing the variable n, which is the moles, the equation for van der Waals equation is usually represented by this value here. Our equation, we have P plus AN squared over V squared multiplied to the V minus NB equals nRT. The P is the value for the atmospheric pressure that you will be looking for. The AN squared here, the A is the value of the represents the correction in volume, and the B represents the adhesive force between molecules. This is the letter B, which represents the adhesive force between molecules. The N represents the moles, the V represents the volume, the N, the moles, or again. Then the capital R represents the constant rate of the ideal gas. And then the capital T is the temperature in Kelvin. All right, take note of that. Now, to proceed, take note that we will be needing the following van der Waals constants of some common gases. We have here the following common gases, and then the A and B, again the A represents the correction in volume, and the B here represents the adhesive force between molecules. All right, so to understand this better, we have here sample problem number 1, given that 3.50 moles of ammonia occupy 5.20 liters at 47 degrees Celsius. Calculate the pressure of the gas in atmospheric pressure using the van der Waals equation. To solve this one, we have to find the given values first. And to find the given values, we have here the following. The value of the A, this one, which came from this table of ammonia here. This one, 4.17, and then the unit, which is ATM, or atmospheric pressure, the liter squared, mole squared, over mole squared. And then the value of your B, this one, which is 0.0371 liters per mole. We get this from here in response to the ammonia unit. All right, and then this is the unit. Now, the next one is the value of your moles, which is 3.50 mole. We get this from the problem here, given the 3.50 moles of ammonia. That is where we derive that data. And then we also have here the value of your volume, which is 5.20 liters. That is 5.20 liters, yes. Again, that came from the problem, occupy 5.20 liters. Remember that the unit of the volume is always in liters. So if the volume of a problem is given in milliliters or centiliters other than liters, you have to convert that unit into liters first, right? Take note of that. And then the value of your temperature is 47 degrees Celsius from the problem again, 47 degrees Celsius here, this one. And then the capital R is the ideal gas constant rate, which is 0.0821 liters multiplied to the ATM over the Kelvin multiplied to the mole unit. And then we have to convert the temperature because the standard unit for the pressure of the gases is always in Kelvin. So you have to convert the degrees Celsius into Kelvin. And to convert the temperature into Kelvin, you have to 47 degrees Celsius plus 273.15, that is 320.15 Kelvin actually, but you can write 320 Kelvin, all right, for simplicity. Now, the next thing that you need to do, since this is the formula for the van der Waals equation, you have to get first the value of your AN squared over V squared, and then get the value of that, plug or substitution. The value of your A, this one, is this, yeah. And then the value of your N or your mole is 3.50 mole. It says squared, so you have to square that. And then over the value of your volume, which is 5.20 L squared, because that is in squared, the variable. And then you have to solve that first. Copy this one, 4.27, then 3.50 mole squared, that is squaring 3.50, that is 12.25 mole squared. Then squaring 5.20, 5.20 squared is 27.04 liters squared. And then you can cancel the units here already. So cancel the liter squared, cancel the liter squared, cancel the mole squared, cancel the mole squared. You will be left out with the ATM unit or atmospheric unit. And then multiply 4.17 times 12.25 and then divide the product to 27.04. You will have 1.89 atmospheric pressure as your answer for this one. And then the next thing that you need to do is find the NB here, mole divided by the value of your B, which is the value of your mole is again 3.50 mole from the given, and then the value of your B is this one, 0.371 liters per mole. Multiplying that, you have to cancel the mole unit. You will be left out with the liter unit, and then multiplying, you will have 0.130 liters. All right. And then you already have the values. The next thing that you need to do is plug the values on your van der Waals equation. So plugging the values, you will have the value of your P. The value of your P is nothing. That is because you are looking for the pressure. And then the value of this one is 1.89 atm from the solving. So you will plug that. Multiply to the value of your volume, which is 5.20 liters from the given. Subtracted to the NB value, which is 0.130 liters, you will have this one. And then substitution, the value of your moles is 3.50 moles from here, from the given values. And then the value of your R is this one, the ideal gas constant rate, 0.0821. And then the value of your temperature, that is 320 Kelvin from this one. All right, 320 Kelvin. Now, the next thing that you need to do, let me change this color into light blue. Multiply this one. Actually, you can cancel the units already. Cancel, 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 cancel. And then you can proceed with the multiplication. That is multiplying this one, the coefficients or numerical coefficients, that is 91.95 atmospheric pressure. Subtract this one, you will have 5.07 liters. And then the next thing that you need to do is multiply 5.07 multiplied to P, that is 5.07 P. And then 5.07 multiplied to 1.89, that is 9.58. And then the next thing you need to do is transpose this one, transpose 9.58 to the other side. Transposing that, you will have a negative value for that. So that will become 91.95 minus 9.58. All right. And then the next thing that you need to do, divide both sides by 5.07. Dividing, cancel this one. You will be left out with a pressure variable. And then 82.37 divided by 5.07, you will have 16.20 atm. The value of the pressure of the gas in atmospheric using the van der Waals equation given this sample problem is 16.2 atmospheric pressure. This is the answer. All right. Now, for sample problem number 2, we have given that 1.32 moles of helium occupy 7.81 liters at 32 degrees Celsius. Calculate the pressure of the gas in atmospheric pressure using the van der Waals equation. Now again, let us proceed in this one. You have to write the given first. All right, 1.32 and then 7.81 liters. Yes, that is correct. And then the next thing that you need to do here, first, you have to find the A. To find the A, that is from here, that is helium, right? That is 0.034, this one. 0.034, and then this is the unit, okay? So this one. And then find the value of your B, which is 0.037 liters per mole from your van der Waals constants. Here's 0.0237, right? Okay, this one. And then the value of your R, which is constant, 0.0821 liters atmospheric over kelvins per mole. The value of your N, that is from the problem, 1.32 moles here. All right, 1.32 moles of helium. And then the value of your volume, which is 7.81 liters here, which is from the problem as well, 7.81. And then the value of your temperature is 32 degrees Celsius. Convert the Celsius into Kelvin by adding 273.15. You will have 305 Kelvin. Now for the solution, you have to find first the AN squared over V squared. You just have to plug the values. The value of your A is this one. Just plug that. Substitution. The value of your mole is 1.32. Then square that because the variable says so, that to square that. And then the value of your volume is from the problem 7.81, then square that as well. And then you have to square This one, 1.32, just write it first here, and then the other one, square that, 1.32 squared, that is 1.74 mole squared, 7.81 L squared, that is 60.996 liter squared, and then multiply, then divide the product to 60.996, you will have 0.0097 atmospheric pressure. This is the answer for that. And then find the value of your NB mole. For the mole, that is 1.32 moles here. And then the value of yours B is this one, 0.0237. Multiply that, cancel the mole unit, you will be left out with the liter unit. Then multiplying, you will have 0.0313 liters. Now, you already have the value, so all you need to do now is solve. All right, solve that. The first thing that you need to do is plug the values. The value of your P is 0.P plus, again, the value of your AN squared is this one, 0.097 ATM. So you will have this one. And then multiply that to the value of your volume, which is 7.81, this one. And then the value of your NB, this one, 0.031 liters. And then plug the value of your moles, which is 1.32 moles here. And then the value of your R, which is 0.821 liters ATM over Kelvin per mole, this one. And then the value of your temperature is 305 Kelvin, this one. And then the next thing that you need to do is multiply this. Let me use a green color here. All right, you have to multiply this. Multiplying that, you can cancel the units already. Cancel that. You will be left out with Kelvin, cancel. You will be left out with 33.05 atmospheric pressure. And then the next thing that you need to do is distribute the multiplication. P multiplied to 7.78, you will have this one, 7.78 P plus 7.78 multiplied to 0.0097, you will have this value. And then the next thing that you need to do is transpose that 7.78 to the other side. Transposing that, you will have a negative value for that. That will become 33.05 atmospheric pressure minus 7.78. Okay, the minus because you transpose the value. All right, from positive, it will become a negative. And then subtract this one, subtract, you will have 33.05 minus 7.78, you will have 25.27 atmospheric pressure. And then divide both sides by 7.78, you will be left out with a pressure variable. 25.27 divided by 7.78, and then that will be the value of your pressure, therefore, is 3.25 atmospheric pressure. This is the answer for the sample problem number 2. All right. Next, sample problem number 3. We have this one. Given that 9.16 moles of krypton occupied 3.26 liters at 12 degrees Celsius, calculate the pressure of the gas and atmospheric pressure using the van der Waals equation. Again, the next thing that we need to do is we have to find first the given, all right? So for the given values, we have the following. Let me use a green. For the value of A, this is that 2.32 atmospheric liters per mole squared, which came from the value of your krypton here in the van der Waals constant, which is 2.32, and then the units here. All right. And then the value of your B is 0.0398 liters per mole, which came from here, 0.0398 liters per mole. All right. And then the value of your R, or the rate of constant for ideal gas, is 0.0821 liters multiplied to 8 atmospheric pressure per Kelvin multiplied to the mole. And then the value of your moles, which is the N, 9.16 mole, this one came from here, from the problem, sample problem number 3, 9.16 moles of krypton. And then the volume is 3.26 liters here. All right. And then the temperature is 12 degrees Celsius from the problem, this one. Then you have to convert the temperature, since the standard is Kelvin. Convert that by adding 273.15. You will have 285 Kelvin for the temperature. Now for the solution, this one, we have to find first the value of A and B, A squared B squared. To find that, will become, plug the values. The A is 2.32 from here. Let me use 2.32 from here. And then the value of your N, 9.16, this one. Square that, 9.16 here. And then the next thing that you need to do is plug the values of your volume, which is 3.26, square that as well. Now, solve that, write the 2.32 again here, then find the square. square value of this one, 9.16 raised to 2. That will become 83.9 moles squared. Then square this one as well, 3.26 raised to 2. That is 10.26 liters squared. And then you can cancel here the units already. Cancel the ATM, cancel the, I'm sorry. Cancel the mole squared, cancel the mole squared, cancel the liter squared, cancel the liter squared. You will be left out with the atmospheric unit. And then multiply 2.32 times 83.9, and then get the product of that, then divide the product into 10.6, you will have 18.36 atmospheric pressure. All right. Now, next thing that you need to do is find the value of your NB. The value of your NB from the N, that is the variable here, 9.16 moles. And then the value of your B is 0.0398 liters per mole. This is that. And then cancel the unit, mole, you will be left out with the liter unit. 9.16 times 0.0398, you will have 0.365 liters. Now the next thing that you need to do is just plug the values here. You will have P, and then the value of your, I'm sorry, excuse me. Let us use a highlighter for this one. All right, the value of your P here, and then the value of your AN squared, V squared is this one, 18.36 atmospheric pressure, multiplied to the value of your volume here, which is 3.26 liters from the given values here, and then minus that to the value of your NB here, 0.365 liters, that one. And then the next thing that you need to do is find the value of your N, plug in that is 9.16 moles from here. And then the value of your R constant, that is 0.0821 liters multiplied to atmospheric pressure over Kelvin per mole. And then the value of your Kelvin is 285 Kelvin for the temperature, or your capital T here. All right. And then the next thing that you need to do is multiply, of course. Multiply this one, and then you can cancel the unit na. You can proceed on canceling the unit here. Cancel, and everything, cancel everything. And then the next thing that you need to do, multiply 9.16 to 0.0821 to 285. You will have 214.3. Then subtract 3.26 to 0.365. You will have 2.895 liters. And then the next thing that you need to do is multiply, distribute 2.85 times P, you will have 2.895 P. And then 2.895 multiplied to 18.36, you will have 53.15. And then the next thing that you need to do is transpose 53.15 on the other side. Transposing that, you will have a negative value for that. You will have 214.3 minus 53.15. Therefore, subtract this one. Subtracting 214.3 minus 53.15, you will have 161.15 ATM. Multiply both sides by 2.895. Cancel 2.895 divided by 2.895, cancel because they are similar. You will be left out with the pressure variable unit here. Then the next thing that you need to do is divide 161.15 divided by 2.895. You will have the value for pressure, which is 55.66 atmospheric pressure. This is the answer. All right. And then last sample problem for this one, you will have here this one. Given that 22.3 moles of argon occupy 4.52 liters at 12 degrees Celsius, calculate the pressure of the gas in atmospheric pressure using the van der Waals equation. So for this problem, we have to find the given again. You will have here the following values. Finding the given, you will have the following. All right, so first you will have the value of your A, which is 1.34 ATM. This one came from here, from the, what's the gas again? Argon. So this is the argon, 1.34, and then the unit. And then the value of your V is 0.0322, and then the unit, this one. All right. Okay, so that is for B. Now the value of your R as well, constant. The value of your mole is 22.3 moles from the problem, 22.3 moles here. And then the volume is 4.52 liters, then temperature is 12 degrees Celsius. 4.52 for volume, then temperature. Then you have to convert the temperature into Kelvin. 12 plus 273.15, you will have 285 Kelvin. For the solution, find first the AN squared over V squared. Then the next thing you need to do is plug the values. The value of your A here, the value of your N, 22.3 squared it as well. Then the value of your volume here. Then copy again. Then get the squared value of this one, 22.3 raised to 2. You will have 497.29 mole squared. The value of your volume, 4.52 squared, that is 20.43 liters squared. You can cancel the units here already, liter squared, mole squared, then multiply 1.34 to 497.29, get the product of that, then divide the product to 20.43, you will have 32.6 atmospheric pressure. The next thing that you need to do is find the value of your NB. To find the value of your NB, plug the values again. The mole is 22.3 moles. The value of your B is 0.3322. Then cancel the mole unit. You will be left out with the liter unit. Then 22.3 multiplied to 0.0322, that is 0.72 liters. And then plug the values here. This one, let me use yeah. The value of your P, you will be looking for that. N squared is this one, 32.6 atm. And then the volume is this one from the given values. Let me use the yellow. This one, 4.52 liters minus the value of your NB, which is 0.72 liters. And then equal that, plug the value of your mole, which is 22.3 moles from the N here. All right. The value of your R, this one, 0.821, this one. And then the value for your temperature is 285 Kelvin, this one. And then the next thing that you need to do is cancel some units and then multiply. Multiply 22.3 to 0.0821 to 285. Cancel the units, the unwanted units. And then multiplying this numerical coefficient, you will have 521.79 atmospheric pressure. And then subtract this one, 4.52 minus 0.72 liters, you will have 3.81 liters. Then multiply distribution property, 3.8 multiplied to P is 3.8 P. 3.8 multiplied to 32.6, that is 123.88. And then this one, then the next thing that you need to do is transpose 123.88 to other side. Transposing that, you will have a negative value. So that will become 521.79 minus 123.88. Okay, upon subtraction, you will have 397.91 atm. Then divide both sides by 3.8 from the P so that you can have the pressure variable. 3.8 divided by 3.8 cancel, you will be left out with the pressure variable. And then 397.91 divided by 3.8, you will have 104.7 atmospheric pressure. This is the value, or this is the pressure, the answer to the sample practice exercise here. All right. So that is some common sample problems for van der Waals equation. Thank you so much.